Hi, this is the introductory lecture for our new course, which is Introduction to Machine Learning in Julia. My name is Dr. Sridat Panat. I graduated with my PhD from MIT in 2022. And prior to that, I finished my bachelor's from IIT Madras in 2017. Although most of my PhD was in experimental electrical engineering and mechanical engineering and robotics, etc., I also ended up working a lot on scientific machine learning, especially using Julia language. Julia is a relatively new language, but it's also very fast growing. And we also ended up publishing some high impact papers very recently in the field of scientific machine learning by using Julia. So I thought there is a very good use case for learning Julia as a language and learning machine learning from scratch and also implement that in Julia. It's very easy to do so. Julia makes your life much more easier in many tasks compared to Python for machine learning. And there is a very niche area where Julia has very high applications. So this course will introduce you to two things. One is it will start completely from scratch for Julia as a programming language. I will cover the installation. I will talk about how to even run your equivalent of Hello World in Julia, run basic loops, etc. I will go through the detailed course content in a short moment. So Julia was invented by a group of people, including a professor at MIT named Professor Alan Edelman. I think they first released their website in 2012, if I remember correctly. And yeah, so this was 2012 year. And then there were other co-founders as well, Jeff Bezanson, Stefan Karpinski, and Viral Shah. So Professor Alan Edelman is now the principal investigator at the Julia Lab. This is the website of the Julia language itself, not that of the Julia Lab. And this is Professor Alan Edelman's website on MIT's domain. So, and there is also one more important name that I have to mention when it comes to scientific computing and scientific machine learning and Julia, which is Dr. Chris Rakaukas, who also works at the Julia Lab. He's the co-PI, co-principal investigator, along with Alan Edelman at MIT. So, and also Dr. Raj from our team, he was a PhD student in the Julia Lab, and Dr. Chris and Professor Alan Edelman were his advisors. So this gave us a lot of deep personal connection with Julia language itself and the big names associated with it. And later, we launched a machine learning boot camp, primarily meant for scientific machine learning, and a big fraction of this is in Julia. So we thought, since many people are interested in learning Julia, it makes sense to release a course which is meant for teaching Julia as well as teaching data science, ML, and DL through Julia. And this was last month. We also ended up publishing a couple of papers. So this paper was about human versus LLM identification with explainability. This was in Python itself, and this was using advanced NLP techniques. We tried to classify between human written versus AI written texts with a high degree of accuracy. And this work was accepted to NeurIPS workshop this year, 2024. And the second work, which was even more interesting, was a study of Chandrasekhar white dwarf equation. We were able to predict what this equation was able to predict using the scientific machine learning framework. And this entire work was done in Julia. So Julia has a lot of applications in high impact research publications. This work was also accepted to NeurIPS workshop. So we thought, okay, if many people are interested to work on impactful research problem statements in scientific machine learning, it makes a lot of sense for them to learn Julia itself from scratch, how to even install, how to run the code, where do you run it on your computer, how to do it on Mac or Windows. Before even you implement machine learning models, how do you run basic functions or basic loops in Julia, and then slowly progress to data visualization, data pre-processing, ML, DL, etc. And we can also do a capstone project in the same. So that's the idea behind this course. And often there is a question, how useful is Julia in the industry? There are, of course, certain companies that really leverage the SciML framework for analyzing the fluid flow around objects. There are F1, Formula One car racing companies who does something similar. Physics X is an example of one such company that uses some kind of scientific machine learning framework for making predictions in real world applications. Pumas AI is another healthcare startup. They have collaborations with other big companies in solving certain challenges with respect to healthcare, and they also leverage the framework and different packages available in Julia. Although the popularity in industry is definitely much less than Python for Julia, there is definitely a niche where there is a lot of scope for early movers and real experts in scientific machine learning or experts in Julia to be part of the industry as well, just like how they can be part of academia. So this course is meant for two groups of people. One is if you are a student who would like to pursue some research in machine learning and who would like to explore the domain of scientific machine learning, Julia is the starting step. So this course will teach you that. This course, although we won't be explicitly covering scientific machine learning because that is anyway covered as part of our bootcamp, we will be teaching you the traditional machine learning techniques themselves. Plus, we'll also be covering a bit of deep learning and as well as data science. I will go through the course table of content in a short while. And the second group of people that I would like to address through this course are industry professionals who would like to do something impactful in ML. Let's say you are working in a domain that is completely different from ML, maybe software engineering or something else. There are a few things that you can do to make your profile aligned towards a machine learning role, or aligned to show that you are a machine learning expert. But one of the mistakes that people do is simply just doing toy Kaggle projects or doing the exact same courses and projects that millions of others are also doing, and thinking wishfully that doing these very popular Kaggle projects or very popular courses from Coursera is going to make a difference in their profile. Of course, that makes a difference in your knowledge, but it does not necessarily make a difference in your profile with respect to millions of others who are also doing the exact same thing. What can make a difference really is if you can build a product or let's say application or a website that is based in AI, which people can use, or which at least you can demonstrate to someone. That can of course make a difference. The other thing that can make a difference in your profile is research. If you can conduct research, high impact research, and present your work at conferences or try to publish your work in prestigious journals, that can also make a difference. And one interesting thing that I have noticed in scientific machine learning especially is that unlike traditional machine learning problem statements, many problem statements which are impactful in SciML is relatively less explored. There are so many low-hanging fruits which are yet to be taken or yet to be explored, which leaves kind of a door open for many people to come and work on some problem statements and get some tangible outcome out of it. So that is the second group of people that I would like to address. Like if you would like to build a strong foundation for scientific machine learning, the initial base has to be learning Julia and learning the various packages, different operations that you can perform. And it will also add another programming language to your arsenal. So it will add ultimately a lot of value to your profile, whether you would like to shift to machine learning or not. So this course will accomplish that. Now, I have prepared a detailed course curriculum consisting of several lectures. So what I'll do is I'll go through in detail what I'm planning to cover in each lecture, totally how many lectures you can expect, and roughly what will be the duration of this course, etc. So this is the PDF that I have downloaded from the Overleaf document. So let's go through this one by one. So I have divided this entire course into certain modules, and within each module there will be a certain number of lectures. So the first module is about basics of Julia programming itself. Then the second module is about data science, so fundamentals of data science in Julia. Third module is about ML in Julia. Fourth is about deep learning in Julia. I'll also be covering a bit of time series analysis. And the fifth and last module is a capstone project. So let me just split these modules into lectures and subtopics that I'll be covering, and also give you a brief idea about what can you expect at the end of this course. So totally, I'm planning 18 lectures, not counting this lecture, 18 more lectures. Each lecture you can expect to be 30 to 45 minutes long. So that will be what, 18 multiplied by, it'll be something like perhaps, let's say 15 hours of course content, something like that. I'm not being exact here, but somewhere around this. So it's not a very long course. It's relatively short because usually the courses that we make are 45 hours long, but maybe maximum this will be 20 hours long. That's what I'm thinking. I'll know the exact number only once I'm actually recording the course. So that's why I can't give you an exact number at this point. So in the first module, I'll talk about Julia in detail as a programming language. Why was it invented? What's the advantage of Julia over, let's say, Python in some cases? Of course, Python is by far the most popular language when it comes to machine learning, no doubt about that. But Julia also is picking up, and in many cases, Julia has found to be tremendously more advantageous. So we'll be covering a bit about all of that. We'll be talking about why exactly should you learn Julia. Then we'll cover installation. This is a pain point. Like, many people have struggled installing Julia in the first place, I know. So we'll be talking about this in detail. And then, of course, how to run Julia in Jupyter Notebook as well as in Visual Studio Code. I'll show that. And then a little bit of the variables, data types, etc., and strings, numbers. So very basic. So this lecture one will be it'll be very basic, but it will help you set up the working environment for the next lectures. So this lecture will be 30-40 minutes long, something like that. Then lecture 2 will be about conditional statements, loops, then defining variables, arrays, tuples, then certain lists, set operations, etc., defining functions, calling them, etc. So lecture 2 will also be roughly 30 to 45 minutes. I'm expecting this lecture 2 to be slightly longer than lecture 1. And lecture 3, I originally did not include this lecture in the course content, but then I later thought it's actually an interesting topic, very interesting topic, in fact, which is of Pluto Notebook. So Pluto Notebook is like, Jupyter Notebook, right? So Pluto Notebook is something that people at Julia has built, and it's very, very interesting. You can run a lot of amazing things there. Like originally when we were building Vizuara's website, right, we actually built Pluto notebooks instead of React web pages. So we have a lot of experience working with Pluto notebooks. It has so many interesting features. So I will show you how to set up like a work environment in Pluto notebook, but we will not be covering a lot of things in Pluto notebook or using Pluto notebook that extensively in the rest of the course. We'll be either using Julia in Jupyter notebook or in Visual Studio Code environment. But I really wanted to talk about Pluto notebook because I'm sure you will find it very interesting. So that will be lecture 3. So combined these 3, so there will be 3 lectures in the module 1, and the total duration would be somewhere around, let's say, maybe 2 hours, something like that, for the module 1. There will be 3 lectures and total 2 hours. In the second module, I plan to cover data science fundamentals. So there are certain libraries that you should be aware of in Julia, similar to packages in Python, right? NumPy, there is TensorFlow. There are so many famous PyTorch, so many famous things in Python that you have to know if you want to become a good data scientist or good ML engineer. Same thing in Julia. I'll be covering certain interesting libraries, loading, analyzing data, etc. So this lecture could be 45 minutes to 1 hour, depending on the amount of subtopics that I will cover. And then a little bit of data cleanup and pre-processing. This you will inevitably end up doing once you are starting to working on a project. And then I'll be covering certain data visualization tools. So in any data science course, you will see these things like data science libraries, data uploading, cleanup, pre-processing, visualization, and then some statistical analysis. So the lecture concept wise, they are very similar to what you will see in any traditional data science course. But here we'll be looking at it from the angle of Julia. We'll be covering particular packages in Julia, plotting libraries, things that will make your life much more easier. So here in lecture 6, I plan to cover several libraries. Some of the examples are plots.jl, Miki.jl, etc. And actually, Julia has a lot of interesting, beautiful plotting techniques. It has beautiful visualizations. You will be mind blown by seeing some of them. So I'll be covering some of that in this lecture 6. Lecture 7 is about some statistical analysis. Some of them are very basic, like this mean, mode, median, mode, etc., and then correlation, covariance, etc. So this also, you may be familiar with this if you have done ML or statistics in Python, but here we'll be doing it in Julia. So overall, this will be this won't be like 4 hours. So this is total 4 lectures. Each lecture probably, let's say, 45 minutes. So this may be 3 hours duration, the module 2. And coming to module 3, in module 3, we'll be looking at various ML techniques. So first, we'll be introducing to ML concepts themselves. And I'm sure if you have taken any machine learning course before, you're already familiar with some of these evaluation metrics, supervised, unsupervised, semi-supervised learning, etc. So there are more sub-concepts that I plan to cover as part of this lecture, as part of this module, but I have only mentioned a few of them because I did not want the table of content to look, a huge thing. But basically, the concept-wise lecture 8 will talk about maybe things that are already familiar to you, because there is nothing Julia specific in lecture 8, but still it'll be a good refresher for you, even if you know it already. Then we'll come to implementing certain machine learning models using Julia. So first, of course, will be linear regression. Needless to say, you can already guess it without even knowing the curriculum. So we'll see different libraries that will help you with respect to this. We'll be doing logistic regression. We'll be covering fundamentals plus implementation in Julia. So this part will actually, the first part of all of this lecture, first half of all of this lecture will actually give you a strong hold on fundamentals if you're not aware about that. If you're already aware about that, maybe you will be able to skip to the second part without even going through the first part. If you already are really good at regression or clustering, if you might be able to skip half of the lecture. But otherwise, just go through it. It'll be a good refresher. If you are a complete beginner, well, that's the best case. Then we'll be covering clustering, k-means clustering, again, a standard machine learning concept, and we'll be covering that theory-wise as well as application-wise in Julia. And then decision trees and random forest. So lecture 12, I expect to be a bit long, probably more than 1 hour. Regression, probably 45 minutes. This will also be 30 to 45 minutes. K-means clustering, maybe 45 minutes. So overall, module 3 will be slightly longer than the per lecture length will be slightly longer than previous modules, but we'll see as we go along with the course. We'll learn that. Then PCA, principal component analysis, also will be roughly 30 to 45 minutes, I think. So this will be 1, 2, 3, 4, 5, 6 lectures, right? And each lecture will be around 45 minutes to even 1 hour. So 6 lectures, and let's say the total duration would be maybe 4 to 5 hours. I cannot say with great certainty right now, but somewhere around that. So this will be ML in Julia. You will get a decent hold on ML in Julia. The fourth module is deep learning, DL in Julia. So here we'll introduce basically neural networks. So we'll look at various libraries. I'll also be covering a bit of fundamentals of neural networks themselves. I have not added that subtopic here as a bullet point, but obviously I'll be covering that too, because I don't want to assume that you are already familiar with some of those things. So I don't want to skip too many things here. So lecture 14 might be a bit long. It might be maybe even 1 hour in duration. But you will learn how to build a simple neural network in Julia. So lecture 14, actually, since it's one of the lectures that actually talk about implementing neural network from scratch in Julia, I might also decide to split it actually. So here I thought, okay, I don't have to unnecessarily increase the duration, because in the previous module itself, you will learn a lot of things about machine learning. And since I don't want to go so deep into neural networks in this course, I thought I will limit the deep learning part into maybe a few lectures. But as I go through the course, if I realize the need to split this lecture into few more number of lectures, the total number of lectures might increase. Currently it is 18. Maybe it will increase to 20, 21, something like that, because I may decide to concentrate a bit more on this part. I'll also talk a bit about the NLP techniques and packages that will allow you to do so in Julia. So lecture 15 will be that. So this will also definitely be minimum 1 hour. The exact duration we are yet to see. Lecture 14, it might be much more than 1 hour. We'll see that. And then a little bit of time series analysis, which may or may not involve deep learning, right? So this I wanted to include include somewhere. And I thought instead of creating a separate module for this, which will anyway be a bit short, I thought I will include this as part of deep learning with Julia. So deep learning with Julia is basically deep learning plus some advanced topics. You can think of this module like that. Topics. So totally there will be, I would say, 3 to 5 lectures. The number of lectures is not completely fixed in this module, and the total duration can be even 5 hours, maybe. It may be 3 hours, it may be 5 hours. So we'll see. Then the last one is where you will build a hands-on project. So I have not fully decided. I have a few topics in my mind, so I have not decided which one to pick exactly. I'll figure it out based on the level of difficulty that I want to put in these projects, in the capstone project. So, but this will be a very good one for you to implement a lot of things in Julia. Like at the end of the day, if you implement this project along with me as part of this course, you will have a really good hold on many packages that we would have discussed in the previous part of the course. So this capstone project will help you build a very good ML model for solving a very specific problem. We'll see if the data we have to find from an existing data set on internet, or we'll figure out something else. So that we are yet to see, because I have 4 or 5 different ideas in my mind. We'll figure out what to put in the capstone project. And the last lecture will be a conclusion lecture where we'll summarize, we'll kind of briefly recap all the concepts that we learned in the course. Plus, I will also talk about some of the other projects that I have in my mind apart from the capstone project, so that you can also identify what other things you can work in Julia. I may add one lecture about scientific machine learning, perhaps somewhere, but not to teach scientific machine learning in Julia, because that is covered in bootcamp, but more about what exactly is scientific machine learning and how Julia helps for that. We won't be teaching scientific machine learning in that course because that will be too much. Then the course will be too long, but I'll at least touch upon that somewhere as part of this course. And I will talk a bit about some of the impactful research problem statements that you can potentially work on, how to identify valuable, such problem statements with data set available, and how you can execute that, and what exactly can you do after this course. So you will get a fairly good idea about that. And if you have your own ideas, project ideas, of course, feel free to reach out to me, and I'll be happy to brainstorm with you. So this is the course structure in a brief nutshell. But of course, as I mentioned, it's a little bit tentative. I may change a few things here or there, but the overall structure would remain pretty much the same. So this is about the course. Now, one thing I want to mention before concluding this introductory lecture and before going into the next lecture is that of the commitment that you need to finish this course, right? So usually what I have seen is the number of people who attend the first lecture is always greater. It's like a declining graph. Always there will be more number of people attending the first lecture. Second lecture will be lesser. Third will be lesser like that. It makes sense because when you are taking a course, some people are just exploring the course, and if they don't like it, they drop off. But if you are a serious person who really wish to make machine learning part of your life, if you really wish to do something meaningful in Julia, I highly recommend you to stick with me till the end of the course. And the number of lectures that I'll be releasing might be such that every week you may have to cover 2 or 3 lectures. So every module might take let's say, since you have 18 lectures, this would be roughly 6, 7, 8 weeks, something like that. So, because every week 2 to 3 lectures, right? Something like that. So it's not exact, but think about that kind of a timeline. And every week, all you need to invest is maybe 1.5 to 2 hours of your time. So if that much time you can manage from your end, I'm sure, rest assured, you will be able to finish the course very smoothly. So I'm sure you will enjoy this course. I really, really love Julia as a language. It's so easy, so intuitive and beautiful. So I hope you do enjoy this course as much as I have done when I first learned Julia. The second thing is about machine learning. If you can identify impactful problem statements and try to execute it in the scientific machine learning framework, the amount of opportunities that you may get are so vast. You may need a team of highly motivated people to work with you to keep you on the toes, to get things done faster and to push things when things are not working. But at the end of the day, if you have that kind of a vision, you can do a lot of things with the help of Julia. So I'm sure this course will not just be yet another course that will help you add Julia programming language as your technical skill in section in your resume. I mean, of course that is fine, but the course should be something beyond that. So I hope it really happens for you, and I will conclude this first lecture here. So I'll see you again in the next lecture, but I wish you can follow with me throughout this course and learn something beautiful and incredible. Thank you so much, and welcome to the course.